can see why people thought of it as
Thanks to NordVPN for sponsoring today's video. The Cassini mission to the Saturn system has captured the hearts of many people across the world. Not only was it a fantastic feat of engineering, it was ambitious with its mission objectives. It was a completely successful mission, and it took some of the most spectacular images of space that we have ever seen. During its 13 years around Saturn, it sent back an incredible 635 gigabytes of data. More than 4,000 science papers have been published. It discovered 6 new moons. It confirmed that icy moons have subsurface oceans of salty, liquid water which may well be habitable. It landed a probe on Titan. It observed Saturn's peculiar storms. And during all this time, it traveled in excess of 7 billion kilometers. In my opinion, and probably in the opinion of many of you, it was one of the greatest missions of all time. Now, I've already covered a lot of the Cassini mission in other videos, but one thing a lot of you have wanted to see were the images it captured near Saturn's end, before it entered Saturn's atmosphere and disintegrated. Some of these final images are fantastic, although be aware that Cassini is not capable of real-time video capture. Still, they are definitely worth having a look at. I'm Alex McColgan, and you're watching Astrum, and together we will discuss the final images Cassini ever took. The final phase of Cassini's mission was the grand finale, where Cassini performed some of the most dangerous maneuvers of its whole mission, missioning into an eccentric, elliptical orbit over the planet's poles, and daringly through gaps in the rings. The last few orbits took it closer to the surface of Saturn than it had ever been before, giving scientists a new view and perspective of Saturn. The first time-lapse we will look at is from the 8th of September 2017, only 1 week before the end of Cassini's mission. One of the main focuses of Cassini during its mission was the moon Enceladus, one of the prime candidates in the solar system to contain life in a subsurface ocean. Cassini discovered over 100 water plumes erupting through the moon's crust from this ocean, water which freezes in the space environment and has now formed the beautiful E-ring around Saturn. This ring is very tenuous, only visible when backlit by the sun, and is potentially the bluest naturally occurring object in the solar system. Here is a great view of Enceladus's effect on the densest part of the E-ring. You can see the plumes disturbing and replenishing the ring. Cassini's final look at Enceladus's plumes were captured in this remarkable time-lapse taken over a 14-hour period. On the 11th of September, Cassini was near the furthest point of its final orbit and captured this beautiful mosaic in natural light. Visible are the thickest of Saturn's rings, D, C, B, A, and F, with Saturn's short shadow being cast over them. Saturn's northern hemisphere was experiencing summer during this time, which means that Saturn's most famous hexagon storm is visible in all its glory. You can also just about notice Saturn's subtle bands in natural light. What's really interesting in this image, however, is that the night side of Saturn is dimly illuminated. This is due to light reflecting off the rings, meaning Saturn's nights in the hemisphere facing the sun don't get that dark. Below the glow of the rings, Saturn is pitch black. As Cassini began to approach Saturn again on the 12th of September, it took images of Saturn's atmosphere near the planet's terminator line. Incredibly, because the sun is so low in the sky here, huge cloud structures can be seen casting shadows that stretch for many kilometers. You may think this is a close-up of Saturn, but actually we are looking at a scene about 5,500 kilometers across. Saturn's moon Titan could easily fit in this shot. Cassini was getting closer and closer to Saturn. On the 13th of September, it peered one last time at Daphnis, a shepherd moon keeping the A-ring in check. The gravity of Daphnis causes ripples in the ring, and some observers will notice ripples in front of the moon as well as behind. This is due to orbital speeds of the rings and the moon. The inner ring orbits faster than Daphnis, meaning the ripples overtake the moon, exposing more ring material to the moon's gravity. On the other hand, the outer ring travels slower than Daphnis, meaning the ripples lag behind the moon. By the time the ring material reaches Daphnis on either side again, the ripples have already smoothed out. On the same day, Cassini had one last look around the Saturn system. It captured a view of Titan, a moon it focused on heavily during its mission, a remarkable world with a thick nitrogen atmosphere. It also peered at Saturn's rings, with the uneven F-ring just about visible at the bottom of the image. And as Saturn got bigger, it took one last look at Enceladus over a 40-minute period before it disappeared from view behind the limb of Saturn. The final image Cassini ever took was looking over the region where it would plunge into the atmosphere. It was nighttime here, and so Saturn is lit up by light reflected off the rings. On the final day, photos were not on the science agenda. As beautiful as they use up a lot of valuable bandwidth, and scientists wanted to get every bit of data real time before the spaceship was destroyed. This was a unique opportunity. We had never probed Saturn before this. When Cassini first hit the tenuous parts of Saturn's atmosphere, it was traveling 123,000 kilometers per hour. The remnants of Cassini's fuel were deployed by its thrusters to keep Cassini's antenna aimed at Earth. At this point, Cassini was 1,900 kilometers above Saturn's clouds. A minute later, these thrusters were firing at maximum capacity to keep Cassini from spinning out of control. Cassini was directly sampling Saturn's atmosphere, but this atmosphere was also heating Cassini up. Just 10 seconds later, the thrusters were overcome, and Cassini began to tumble, cutting off communication with Earth. Cassini's onboard computers at this point would have been trying to figure out what was going wrong. Gyroscopes and star trackers would tell the computer that it is spinning, and it would likely have gone into a safe mode to divert power in an attempt to right itself. A minute or so later, the spacecraft would have disintegrated altogether and burned up in Saturn's atmosphere. As data started arriving 1.5 hours later on Earth, this final part of the mission was deemed to be a great success. Cassini recorded data from direct analysis of Saturn's atmosphere, its ionosphere, dust particles in the atmosphere, and from magnetic field measurements, and perhaps more that has yet to be uncovered from the data. And that's the amazing thing about the Cassini mission. It just keeps on giving. Science papers and discoveries are still being made as the data it collects is being analyzed and re-examined. And great news, missions to the Saturn system do not end here. Titan will be getting a lander named Dragonfly, which will actually be a drone powered by a radioisotope thermoelectric generator, and its mission is to fly around Titan, directly sampling Titan's surface in various locations. So, there we have it, a look at the legacy of Cassini and of its spectacular final images. Did you know that spacecraft use something known as the Deep Space Network with mission controllers on Earth? These are giant communication facilities around the world so that no matter the orientation of Earth, spacecraft like Cassini can send back data. You too send and receive data all the time over the internet, some of which you may not want unscrupulous people to see, like credit card info and personal information. This is why NordVPN may be of interest to you. NordVPN will provide double encryption for your data, so that you can make a purchase online while at an airport or a coffee shop and still be secure. NordVPN is also available throughout the world, even China, and it allows up to 6 simultaneous connections, meaning that you and your family can still access Netflix or Amazon Prime Library while abroad with their unlimited bandwidth. Plus, you can be safe in the knowledge that you are protected. Use the link nordvpn.org/Astrum and use the coupon code Astrum at checkout, and you can get 70% off their 3-year plan, plus an additional month for free. If you want any more info about NordVPN, check out the link for their YouTube channel in the description. Thanks for watching, and a big thank you to those of you who support this channel in whatever way that may be. For those of you that are interested, description and use the discount code EARLYBIRD to get a 15% discount until the 30th of June. I hope you like. In 1977, two pioneers might be one of the most epic feats of exploration ever undertaken. Their goal? To unravel the cosmic mysteries surrounding the solar system and our place in it. Not only did they provide us with some of the first and best imagery of our solar system's outer planets, but they continued to send us incredible new information about our universe from interstellar space, some 47 years and 24 billion kilometers later. The Voyager 1 and 2 probes are more than just instruments and circuitry. They are a symbol of humanity at its best. Curious, audacious, ambitious, and resilient. Voyager didn't just capture dazzling photos of our gas giants and their moons. It captured the hearts and minds of generations back home on Earth. When I look back, I realized how little we actually knew about the solar system before Voyager, says Voyager mission project scientist Edward Stone. We discovered things we didn't know were there to be discovered, time after time. I'm Alex McColgan, and you're watching Astrum. Join me today as we trace Voyager's iconic journey in pictures, from the splendor of Jupiter to Saturn's icy rings, to the topsy-turvy world of Uranus, to the mighty storms of Neptune. We explore what this mission taught us about our planetary neighborhood. On the 20th of August 1977, NASA launched the Voyager 2 space probe from Cape Canaveral, Florida. Its partner in crime, Voyager 1, was launched 2 weeks later on the 5th of September. Even though both probes were Jupiter-bound, Voyager 1 was set on a shorter, faster trajectory, so taking off second made sense. It overtook Voyager 2 on the 15th of December 1977 and exited the asteroid belt first. Together, this dynamic duo was set to take advantage of a once-in-176-year planetary alignment. Jupiter, Saturn, Uranus, and Neptune were going to be aligned in a way that would allow one mission to explore all four gas giants, an opportunity NASA simply refused to miss. After some back and forth with the US Congress, a few surrounding budget approvals, and a decade of hard work, the Voyager probes finally made it to the launch pad, heralding a new era of space exploration. The dazzling parade of pictures Voyager would send back were absolutely revolutionary at the time. But don't take my word for it. Let's jump in and you'll see for yourself. 13 days after launch, Voyager 1 sent this photo back to Earth. The first of tens of thousands it would send back over the next 5 years. Taken 11.6 million kilometers from Earth, it's a sentimental place to start our journey. It might remind you of the Earthrise photo taken by the Apollo 11 crew from just 8 years prior. We can see our blue marble and its moon in the distance. I don't know about you, but I find this photo so hauntingly beautiful, especially knowing how far this probe had traveled and how much it's seen since then. But we've got a long way to go, so let's move on. It would be almost 2 years before Voyager 1 finally makes its approach to its first target, Jupiter. Not bad, considering it's 714 million kilometers away. Voyager 1 arrived first on the 5th of March 1979. You see, it travels at 17 kilometers per second, 2 kilometers per second faster than Voyager 2, who, leaving Earth first, arrived 4 months later on the 9th of July 1979. This is because the trajectory Voyager 1 took allowed it to gain more speed relative to the Sun. Now, Voyager 1 was not the first spacecraft to encounter Jupiter. That was Pioneer 10, 7 years prior in 1972. And while the Pioneer mission certainly provided great scientific insights, it didn't quite grab the imagination of the public. But sending back stunning images like this, Voyager certainly did. This is Jupiter in all its glory. It's kind of hard to accept that these are actual photos and not paintings or some AI-generated image. If you look closely, you can spot 2 of its moons, Io on the left and Europa, the beige one, on the right, but more on them later. Luckily for us, Voyager 1 even recorded its approach to the Great Gas Giant. It took photos at regular intervals, every 10 hours, or 1 Jupiter day. This means the planet is in the same point of its rotation in all the photos. The 66 photos were spliced together to create this time-lapse movie, spanning Voyager 1's approach to Jupiter from the 6th of January to the 3rd of February 1979, covering a distance of 27 million kilometers. I personally can't decide if it is incredible or terrifying. But let's get a closer look and see what surprises this planet is hiding. Something that immediately stunned scientists was Jupiter's atmosphere. They expected to see east-west and west-east winds in Jupiter's different atmospheric zones, but what caught them by surprise was the amount of